Hello and welcome to my YouTube channel. Today we shall be discussing on the theory of quadratic equations. The standard form of a quadratic equation is an equation of the form ax squared plus bx plus c equal to 0, where a, b and c are numbers and a is not equal to 0. So we observe that a quadratic equation is an equation in which the highest power of x present is 2. So a, b and c are numbers, and in particular a cannot be 0 because if a is 0, then 0 times x squared is 0, and what we have left becomes bx plus c equal to 0, and this is clearly no longer what? Quadratic. So for an equation to be quadratic, the coefficient of x squared must not be 0. B can be 0, c can be 0, but a cannot be 0. Examples of quadratic equations are the following. 1. X squared minus 3x plus 2 equal to 0. Now if we compare this equation with the general form, we see that a here is 1. That's the coefficient of x squared. Our b here is negative 3, the coefficient of x, and our c here is 2. Second example is 4x squared plus 2x plus 1 equal to 0. Again, if we compare this to the general form, we see that a here is 4, b is 2, and c is 1. So these are two examples of quadratic equations, and of course we have many more of them. One of the methods we employ in solving such equations is the method of factorization where it is possible. For example, we shall solve x squared plus 2x minus 8 equal to 0, by method of factorization. Here, a is 1, b is 2, and c is negative 8. The very first step in this method is to multiply a and c. So a is 1, multiplied by c, c is minus 8, so that 1 times minus 8 is equal to minus 8. The next step is to seek two numbers, or look for two numbers rather, such that the sum of these two numbers will be the middle term here 2, and the product of the same two numbers will be the term minus 8. So we look for two numbers such that the sum of the two numbers is 2, the middle term, and the product of the same two numbers is minus 8, that is c. So let's examine the following numbers, 4 and minus 2. Let's see what happens. If we multiply 4 and minus 2, so 4 times minus 2 is equal to minus 8, which is correct. And then if we add up 4 plus minus 2, is the same thing as saying 4 minus 2, which is 2. So we've gotten our numbers. The numbers are 4 and minus 2, because 4 plus minus 2 is 2, the middle term, and 4 times minus 2 is minus 8, the third term c. Now that we've got the two numbers we are looking for, 4 and minus 2, the next step is to replace the middle term 2x, with what? 4x and minus 2x. So the equation becomes x squared plus 4x minus 2x, then minus 8 equal to 0. We replace the middle term with the two numbers we have found, 4 and minus 2. So 2x becomes 4x minus 2x, and of course this is still 2x. We now have 4 terms in an equation, so it is now possible to factorize. So we'll group them in pairs. So for the first pair, what is a common factor? This is x squared, this is 4x, so x is certainly a factor. If you factorize x, what is left? We have x plus 4. In the second bracket, we have negative 2x minus 8. 2 is a factor of 8. So we factor out minus 2, and we have x plus 4 equal to 0. Now let us check to see if our factorization is correct. X times x is x squared. X times 4 is 4x. Minus 2 times x is minus 2x. And minus 2 times 4 is minus 8. So what we have factorized is correct. These two brackets are the same. We now take just one of them, x plus 4. We now bring in x and minus 2 in the second bracket equal to 0. Now this bracket times this other bracket is equal to 0. This can only be 0 if the first one, x plus 4, is 0, or the second bracket, x minus 2, is 0. And this is called the principle of zero product. That the product of two numbers can only be 0 if either of them is 0, or both of them are 0. So if we now solve this, from the first one we have that x is equal to negative 4, or x is equal to 2. So the solution to our quadratic equation, x squared plus 2x minus 8 equal to 0, is x equal to negative 4 or x equal to 2. And we've just solved this equation using the method called factorization. And I'd like to point out at this point that this method only works when there are factors. So in some instances, the method of factorization does not really work. Another method which could be employed in solving quadratic equations is the method of completing the squares. Now, if that method is applied to the general quadratic equation ax squared plus bx plus c equal to 0, it leads us to getting what we call the quadratic formula, and we'll be working with that in this video. The quadratic formula is given as x equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. Now, we shall be spending some time, studying the behavior of this formula. First comment I want to make. Now, we see plus or minus here. This will tell us that this quadratic equation will have at most two solutions. One may be positive and the other may be negative. And it is so because the highest power of x is 2. So we expect two solutions. Now, another advantage is this. With this formula, we can solve any quadratic equation, faced. Meanwhile, in the first method, we are only restricted in the sense that that method can only solve, an equation that is factorizable. But the formula method can solve any given quadratic equation. The example we solved earlier was x squared plus 2x minus 8 equal to 0. And we solved it, using method of factorization. And the solution we obtained were x equal to minus 4 or x equal to 2. Now, we want to solve this same problem using the formula method to see if our solution will be the same. So what we need to do is to identify what our a, b, and c are in the given equation. So if we compare the given equation to the general equation, we see that a is 1, b is 2, and our c is negative 8. So in the formula, we simply substitute 1 for a, 2 for b, and minus 8 for c. This becomes x equal to minus b. What's our b? b is 2, so that is minus 2 plus or minus the square root of b squared. Our b again is 2, so 2 squared minus 4 ac. That means 4 times a times c. So 4 times a, our a is 1, so 4 times 1 times c. Our c is negative 8 times minus 8. Divide by 2a. 2a means 2 times a. So 2 times our a is 1. So 2 times 1. So this gives us minus 2 plus or minus the square root of 2 squared is 4. Now 4 times 1 is 4. And 4 times minus 8 is minus 32. And we have a minus sign here already. So minus 4 times 1 times minus 8 is plus 32. Divide by 2 times 1 is 2. If we simplify further, we get that x is equal to minus 2 plus or minus the square root of 4 plus 32 is 36. Divide by 2. So that the square root of 36 we know is 6. So this becomes x equal to minus 2 plus or minus 6 over 2. At this point, we'll now split our solution into two parts. So we now have that x is equal to minus 2, the first part is plus 6 over 2, or x is equal to minus 2, the second part is minus 6 over 2. So from the first part, we have x is equal to minus 2 plus 6 is 4, so that is 4 over 2, or x is equal to minus 2 minus 6 is minus 8, so we have a negative 8 over 2. So if we divide, we have that x is equal to 4 divided 2 is 2, or x is equal to minus 8 over 2 is minus what? 4. So we observe that the solution we have using the formula method agrees with the solution we had using the method of factorization. And of course, like I said earlier, this method of formula can solve any given quadratic equation. We shall delve a little bit more into the theory of the quadratic formula. Now, the quantity b squared minus 4ac that is inside the square root sign, that is b squared minus 4ac, plays an important role in the theory of quadratic equations. And for that, we give it a special name, and we call this term the discriminant. The discriminant. We call it the discriminant. And usually we denote it, with capital letter D. Capital letter D. So we'll just write that capital letter D, discriminant, is equal to b squared minus 4ac. We cannot study, the properties of this formula without paying special attention to the behavior of the discriminant. So we make the following remarks. Number 1, if the discriminant b squared minus 4ac is positive, that means it's greater than 0, it will mean that the quadratic equation we are about to solve, will have two distinct real solutions. We'll have two distinct real solutions. Now, what this is saying is that if we are given, an quadratic equation to solve, we can know beforehand the nature of the solutions, or what they call the roots of the equation, solutions or roots of the equation, even before solving it. What do? We simply check the behavior of the discriminant. So we are saying here that if we check b squared minus 4ac, and what we have is a positive number, then it would mean that the solution of the equation we're about to solve will be distinct in the sense that they will be different. For example, like what we solved earlier, we had minus 4 or 2. These are distinct roots because minus 4 is not the same as 2, so they are different, they are distinct. And the second thing is that the roots will be real. So a number is either real or complex. So in this case, if this term is positive, we are sure that we are going to have distinct roots, and the roots are going to be real also. For instance, if we have the equation 2x squared plus 7x plus 3 equal to 0, this is clearly a quadratic equation. So we want to investigate the nature of the solution of this equation, or the nature of the roots of this equation, even without solving it. All we need to do is to investigate how the discriminant behaves. So the discriminant is b squared minus 4ac. So we'll take out what our a, b, and c are. It is obvious that our a in this example is 2, our b is 7, and our c is clearly 3. So that b squared is 7 squared minus 4ac means 4 times a times c. So 4 times a is 2 times c is 3. 7 squared is 49 minus 4 times 2 is 8. 8 times 3 is 24. 49 minus 24 is 25. And 25 is clearly a positive number. That means 25 is greater than 0. So what does this tell us about our equation? This tells us that if we solve this quadratic equation using any method that we know, either by method of factorization or the formula method, we are sure that the roots or the solutions of this equation are going to be 1, distinct, that means different, and 2, they are going to be real roots. Remark number 2. If the discriminant b squared minus 4ac is now negative, then it would mean that the quadratic equation we are about to solve will have complex roots, or complex solutions. Like I said earlier, a number is either real or complex. Now, later on in this course, we shall look at the theory of complex numbers in details. But for now, let's just have this in the back of our minds. A complex number is simply a number that has the letter I attached to it. So a number is either real or complex. So for real numbers, you just see 2. For example, is a real number. And if 2 is a complex number, you see something like, say, 2i. So this i is called imaginary part, and is what makes a number complex. So we are saying here that if you test the discriminant of an equation given to you, and the result you have is negative, this tells you that when you solve the given equation, you are sure to have complex solutions or complex roots. For example, if we are given the equation 7x squared plus 2x plus 1 equal to 0, and we are asked to investigate the nature of the roots of this equation or nature of the solution of this equation, what we simply do is to check the discriminant of the equation and see what happens. So if we compare what we are given to the general equation, we see that our a is 7, our b is 2, and c is 1. So that the discriminant, which is b squared minus 4ac, is equal to what? B is 2. So we have 2 squared minus 4ac, 4 times a. A is 7 and c is 1 times 1. So if we work this out, we get 2 squared is 4 minus 4 times 7 is 28. 28 times 1 is 28. So that is 4 minus 28. So 4 minus 28 is clearly negative what? 24. And minus 24 is less than 0, meaning that minus 24 is a negative number. So what this tells us is that if we solve this equation, 7x squared plus 2x plus 1 equal to 0, the roots or the solutions we are going to get will not be real but complex what? Roots or complex solutions. And of course, this is a kind of an equation that cannot be solved by method of factorization. So to solve such an equation, we only employ the formula method of quadratic equations. Remark number 3. If the discriminant b squared minus 4ac is equal to 0, then this tells us that the equation we are about to solve has only one real solution. Only one real solution. Just one real solution. Or sometimes we say that it has repeated solution. It has repeated what? Solution. So how do you know that an equation will have one real solution or repeated solution? You know if the discriminant of that equation is 0. For example, if we are given the equation x squared minus 4x plus 4 equal to 0, and we are asked now to investigate the nature of the roots or nature of the solutions of this equation, then we'll check out the discriminant. But first of all, our a is 1 in this case, our b is negative 4, and c is 4. Then the discriminant b squared minus 4ac will now be equal to, our b is minus 4, so we'll have minus 4 all squared minus 4ac means 4 times a times c. 4 times a is 1, c is 4. So that minus 4 all squared is 16 minus 4 times 1 is 4, and 4 times 4 is again 16. So 16 minus 16 is 0. So what do we see? The discriminant d equal to b squared minus 4ac is clearly 0. So what does this tell us? This tells us that this equation we're about to solve will have one real solution or repeated solution. let's solve it so we understand better what we're saying. So let's do it very quickly. X squared minus 4x plus 4 equal to 0. I want to solve this using the method of factorization. So what's the first step? We multiply a and c. Our a is 1 and our c is 4. So a times c is 1 times 4 equal to 4. We now look for two numbers, if you recall, such that when we add these two numbers, we get minus 4, the middle term. And when we multiply the same two numbers, we get 4, the third term. Those numbers clearly are negative 2 and negative 2, because minus 2 times minus 2 is 4, and minus 2 plus minus 2 is the same thing as minus 2 minus 2, and that is minus 4, the middle term. So our values are minus 2 and minus 2. The next step is to replace the middle term minus 4 with our new terms, minus 2 and minus 2. So this becomes x squared minus 2x minus 2x plus 4 equal to 0. Again, we pair the numbers and factorize. In the first bracket, we can factorize x, and we have x minus 2 left. In the second bracket, we can factorize minus 2, and we have x minus 2 also left. We'll take a second to confirm if we are correct or not. X times x is x squared. X times minus 2 is minus 2x. Minus 2 times x is minus 2x. And lastly, minus 2 times minus 2 is plus 4. So these two brackets are the same again. We take just one. So we take x minus 2. And we take this term x and then minus 2 equal to 0. And from how we solved the first example, we say that x minus 2, the first bracket, is equal to 0, or x minus 2, the second bracket, is equal to 0. And of course, you observe here that the both brackets are the same. So let us solve. So this gives us x equal to 2, or x equal to 2 the second time. So what do we see? We see that the only solution here is x equal to 2, since they're the same. Or you say that x equal to 2 is repeated, hence the name. So we say that when the discriminant b squared minus 4, the discriminant is 0, it tells us that the equation we're about to solve will have one real solution or a repeated word solution. If the equation x squared minus 3x plus 1 equal p into x minus 3 has equal roots, that's the keyword, has equal roots, find the possible values of p. Now, we have to be very careful with this problem. We're given an equation x squared minus 3x plus 1 equal to p into x minus 3. We are asked to find the possible values of p. But what we have been told in this problem, or in this example, which is going to be our guiding principle, is the fact that we are told that this equation rather, has equal roots. And when we say equal roots, we are saying repeated roots. In our last example, we had x equal to 2 or x equal to 2. So we had equal roots or repeated roots, or you say that 2 was the only solution. So I've been told here that this equation here has equal roots. And what do we know about equal roots? We know that if the discriminant d equal to b squared minus 4ac equal to 0, then the equation will have equal roots, equal roots, repeated roots, or will have just one real solution. But before then, we like to rewrite the given equation in a standard form, which is ax squared plus bx plus c equal to 0. So to do that, we must take this term on the right hand side to the left. So this becomes x squared minus 3x plus 1. This is p into x minus 3 to the left becomes minus p into x minus 3 equal to the right hand side becomes 0. So we'll open up the brackets and take like terms. This becomes x squared minus 3x plus 1. So minus p times x is minus px. Minus p times plus 3 is, minus p times minus 3 is plus 3p equal to 0. So if we factorize or take like terms again, there is x and there is x here, so I can bring them together. I have x squared minus into 3 plus p plus 1 plus 3p equal to 0. Let's take a look. X squared minus 3 plus p, so that minus, and of course x, minus, so that 3 times x is minus 3x, and then minus p times x is minus px, that's correct. Plus, now these terms without the x, 1 has no x, and 3p also has no x. So I put them together as 1 plus 3p. Now, if you compare this, what we have now, to the general equation, you observe that our a is what? 1. Our b is negative 3 plus p. And our c is 1 plus 3p. Now we know that for equal roots, what happens? The discriminant d equal to b squared minus 4ac must be what? Must be 0. We know that. We are told that the equation has equal roots. And that only happens when the discriminant is 0. So, what is our discriminant in this case? B squared minus 4ac. Our b is minus into 3 plus p. So we have here minus into 3 plus p all squared minus 4 times a. Our a is 1 times c. Our c is 1 plus 3p. I put in bracket equal to 0. So we're going to work on this equation and find the possible values of p. So for the first one, this is negative into 3 plus p all squared. So minus all squared is plus. What we have left there is 3 plus p all squared. Then minus 4 into 1 plus 3p equal to 0. I want to expand it carefully and slowly. So 3 plus p all squared, simply means 3 plus p times 3 plus p 2 times. Minus 4 times 1 is 4. And minus 4 times 3p is minus 12p equal to 0. Let's open up this bracket. We have 3 times 3, 9. 3 times p is plus 3p. P times 3 again is plus 3p. And then p times p is p squared. Minus 4 minus 12p equal to 0. We'll now take like terms and rearrange what we have. So this is 9. 3p plus 3p is clearly 6p plus p squared minus 4 minus 12p equal to 0. Then 9 minus 4 is 5. 6p minus 12p is minus 6p plus p squared equal to 0. So let us rearrange it one more time so to look like the general form, and we'll be having what? We have p squared minus 6p plus 5 equal to 0. And what we have here becomes our new quadratic equation which we have to solve. So let's see if we can solve this equation using method of factorization. So our first step again is to multiply a and c, and here a is 1 and c is 5. So 1 times 5 is 5. We now look for two numbers such that when we add these two numbers we get negative 6, and when we multiply the same two numbers we get 5. So take a second and sort out the numbers. The numbers are clearly minus 5 and minus 1, because minus 5 times minus 1 is 5. And if we add up, minus 5 plus minus 1 is the same thing as minus 5 minus 1, which is minus 6, the middle term. So our values are the numbers we're looking for are minus 5 and minus 1. So what's the next step? We now replace the middle term minus 6p with what? Minus 5p and minus 1p, which is minus p. So we now have, this now becomes p squared minus 5p minus p plus 5 equal to 0. And like we always did, we now group them in pairs and factorize. So from the first bracket, we can factorize p, and we have p minus 5. Second bracket, we can also factorize minus p, and we have p minus 5 equal to 0. We stop to check if we are correct or not. p times p is p squared, p times minus 5 is minus 5p, minus, oh, this is minus 1. So that minus 1 times p is minus p, and minus 1 times minus 5 is p. So we take one of these brackets, that becomes p minus 5, and then p minus 1 equal to 0. If we solve this like we've always done, we have that this means that the first bracket, p minus 5 is equal to 0, or the second bracket, p minus 1 is equal to 0. If we now solve, we have that p is equal to 5 or p is equal to 1. So the question said we should find the possible values of p. From what we've done, the possible values of p are p equal to 5 or p equal to 1. All we've done in this problem is to employ the idea of the discriminant of our equation. We're told that the equation has equal roots, and we know that if a quadratic equation has equal roots, then we're guaranteed that the discriminant of that equation must be 0. From this, we're able to sort the problem out. I'd like you to try this out on your own. If the equation x squared plus px plus 9 equal to 0 has equal roots, again you have been told that the equation has equal roots, you should find the possible values of p. So you employ the knowledge of discriminant here, just like we did in the previous example, and sort this out. You can drop your answers in the comment section below. Now we want to take a closer look at the roots of quadratic equations. Roots of quadratic equations. In our very first example in today's lecture, we were given the equation x squared plus 2x minus 8 equal to 0 to solve. And after solving it by method of factorization, we arrive at the answers or solutions x equal to minus 4 or x equal to 2. Now the question is this. Suppose you are given the solutions or the roots of the quadratic equation. Is it possible to get back the quadratic equation whose roots have been given to you? The answer is yes. Now let us see how. So let's assume that you have been given, you are told that the roots of a certain quadratic equation are negative 4 or x equal to 2. Question now is, what is that quadratic equation with the roots? So all we need to do is to work backwards like we did before. So here we have x equal to minus 4 or x equal to 2. These are the roots given to you of some equation which we do not know. So we rearrange. We now take minus 4 to the left and take 2 to the left. And we have x plus 4 equal to 0 or x minus 2 equal to 0. From here, we now see x plus 4 times x minus 2 equal to 0. This is true because if we had this, we would have written this directly from it. So we're going in the reverse order. X plus 4 equal to 0 or x minus 2 equal to 0 is the same thing as x plus 4 into x minus 2 equal to 0. Now if we open up the brackets, we have x times x is x squared, x times minus 2 is minus 2x, 4 times x is plus 4x, and finally 4 times minus 2 is negative 8 equal to 0. If we rearrange this properly, we have x squared minus 2x plus 4x is 2x minus 8 equal to 0. And this takes us back to the original quadratic equation. So what we have shown here is that if we are given a quadratic equation to solve, it is possible to solve and get the roots of the equation. And if we are also given the roots of the equation, it is possible to go back to get a quadratic equation whose roots have been given to us, just like I've demonstrated in this example. Now let's take a closer look at these roots in a general case. So let's consider again our general equation ax squared plus bx plus c equal to 0. And suppose we are given or we are told that the two roots of the equation are x equal to alpha and x equal to beta. We are told that x equal to alpha and x equal to beta are the solutions are the two solutions or the two roots of the equation. Then, is it possible to get, so just doing what we had done here, what happens? So this means that the quadratic equation whose roots are alpha and beta, like we did here, will be x minus alpha, x minus beta equal to 0. We did that here already. We had here x plus 4, x minus 2 equal to 0. So if x equal to alpha and x equal to beta are the two solutions of this equation, then we can write this as x minus alpha into x minus beta equal to 0. So if we expand, we get x times, this is x rather, x times x is x squared, x times minus beta is minus beta x, minus alpha times x is minus alpha x, and minus alpha times minus beta is plus alpha beta equal to 0. We can now rearrange to get x squared minus alpha plus beta x plus alpha beta equal to 0. Let us check. Minus times alpha is minus alpha x, minus times beta is minus beta x. That is correct. Equal to 0. So we shall call this equation 1. Now, this is our general equation, ax squared plus bx plus c equal to 0, whose roots are x equal to alpha and x equal to beta, can be rearranged. If we divide all through by a, then what you're going to have is x squared plus b over ax plus c over a equal to 0. And I want to call this one equation 2. So what are we saying? Ax squared plus bx plus c equal to 0 is our general equation. X equal to alpha, x equal to beta are the two roots or the two solutions of this equation. And now when we put it here, we now see that this is the same thing as x squared minus alpha plus beta x plus alpha beta equal to 0. And the same equation can be expressed as this, x squared plus b over ax plus c over a equal to 0. So these two equations are equivalent since they both have the same roots, alpha and beta. Since they're equivalent mathematically, we can write them thus. We can write x squared minus alpha plus beta x plus alpha beta equal to 0 is equivalent as the second one, which is x squared plus beta over ax plus c over a. So we can now compare coefficients. We can now compare the coefficients, and this will give us some interesting results. So we have x squared here and we have x squared on the right hand side. The coefficient of x squared is 1 here, same here 1. So 1 is equal to 1. That is fine. We now move to the next variable x. The coefficient of x here is negative alpha plus beta, and the coefficient of x on this other side is b over a. So minus alpha plus beta is the same thing as b over a on this other side. So we can rearrange this to write alpha plus beta equal to minus b over a. And this is what we refer to as the sum of roots. What we are saying here is that, recall we had said that alpha and beta are the two roots of the equation. So we are saying that when you add, the two roots, alpha and beta, is the same thing as minus b over a. Of course, where b and a are the constants of the equation given to us. And if we compare again, we see that the constant term, on the left hand side is alpha beta, on the right hand side is c over a. We now see that on the left hand side, alpha beta is the same thing as c over a. And this is what we refer to as the product of roots. Now what this is saying essentially is this, that to find the sum of the roots of a quadratic equation, we do not even have to solve it. All we need to do is to know and remember that the sum of roots alpha and beta is equal to minus b over a, and the product of roots alpha beta is c over a. We shall now take one or two examples to illustrate how this is applicable. We are asked to write down the sum and product of the roots for the following equations. Number 1, x squared plus 2x minus 8 equal to 0. And this is our first example again. And number 2, 2x squared plus 12 minus 3 equal to 0. Let's talk about the first one first. If you recall, we had solved this problem already, and we had the roots as x equal to minus 4 or x equal to 2. So in terms of alpha and beta, we can say that our alpha here is minus 4 and our beta is what? Is 2. So let us see what the sum and the product of root will be here before we now check with the formula. So alpha plus beta, which is sum of root, will be what? Alpha is minus 4 plus beta is 2. So the sum of the roots of this equation that we had solved earlier is minus 2. And the product alpha beta is equal to alpha is minus 4 times beta is 2. That is minus what? 8. So for the problem we have x squared plus 2x minus 8, which had been solved, we have that the sum of root is minus 2 and the product of the root is minus 8. Now let's use the formula we just derived to see if it will correspond with what we have. So first, a here is 1, our b is 2, and c is negative 8. So from what we had derived earlier, we said that sum of roots alpha plus beta is equal to minus b over a, and the product of the roots alpha beta is c over a. So here we are assuming that we do not know what the roots are here. So let alpha and beta be the roots, okay? So let alpha and beta be the roots of the given equation. Then we know that the sum alpha plus beta is equal to minus b over a, and that gives us minus, what is our b? Our b is 2, so that is minus 2 over a. Our a is 1, minus 2 over 1, and that is what? Minus 2. So the sum of the roots alpha plus beta is equal to minus 2. Let us see whether what we had here. Yes, we had alpha plus beta equal to minus 2. So it corresponds. Let us check for the product of roots. So the product of the roots alpha beta is what? C over a. And that is equal to c is negative 8 minus 8 over our a is 1 over 1. And what is that? Minus 8. What happened? It corresponds to what we have. So what do we observe? We observe that with alpha plus beta equal to minus b over a, we get the correct sum of the roots of an equation even without knowing what the roots of the equations are actually. So let's solve the second problem or second example instead. So here a is 1, our b, beg your pardon. So here a is 2, b is 12, there's an x here, b is 12, and our c is negative 3. So let alpha and beta again be the roots of this equation. We don't know what they are, but let's just call them alpha and beta. Then we know that alpha plus beta is minus b over a. So that is equal to minus b is 12 over a. A here is 2 over 2. That gives us negative 6. So what we are saying is that if we solve this equation and get two roots, when we take the sum of the two roots, we shall have minus 6. You may want to pause the video here and try it out yourself. And we also know that alpha beta, which is the product of roots of our equation, is c over a. And what is our c? C here is negative 3, and our a is what? 2. So the product of the root alpha beta is minus 3 over 2. Once again, solve the equation, get your two roots, and confirm that the product of the two roots gives us negative 3 over 2. Example. Given that alpha plus beta equal to 4, this means the sum of the root equals to 4, and alpha beta equal to 7. We should find the following value. We should find the values of the following: 1 over alpha plus 1 over beta, 2 alpha squared beta squared, 3 alpha squared plus beta squared. So what we are given in this problem is we are given the sum of the roots of an equation which we do not know, but we are told that the sum of roots, whatever they are, is 4, and the product of the same roots is 7. So we want to use these two information here to evaluate what we are given. Now, how we go about this? There are only two things we know as far as the roots of an equation or the roots of a quadratic equation are concerned. And the two things we know are: one, we know that the sum of roots alpha plus beta is equal to minus b over a. And the next thing we know is that the product of root alpha beta is equal to what? C over a. So the idea behind solving this kind of problem is this: we try to simplify whatever it is we are trying to solve in such a way that the only terms that will be found in our problem are alpha plus beta and alpha beta, or any of them. This is what I mean. For example, in this number one problem, it asks to evaluate 1 over alpha plus 1 over beta. We do not know what alpha is, neither do we know what beta is, but what we know is that alpha plus beta is 4 and alpha beta is 7. So all we need to now rewrite this expression in terms of alpha plus beta and alpha beta only. So the first thing we shall think of here is taking the LCM on both sides. Taking the LCM. So the LCM of alpha and beta is alpha beta. So that if alpha beta divides alpha, alpha and alpha will knock off and we have beta left. And beta times 1 is beta, plus if alpha beta divides beta, beta is gone, alpha is left, alpha times 1 is alpha. So what we have is now beta plus alpha all over alpha beta, which we may rewrite as alpha plus beta all over alpha beta. Now what do you see? We now have two terms. The first term is alpha plus beta, which we know. The second term down is alpha beta, which we know. So from 1 over alpha and 1 over beta, which we do not know, since we don't know what alpha and beta are, we now have alpha plus beta over alpha beta. So this gives us, we are told that alpha plus beta in a problem, that alpha plus beta is 4. So alpha plus beta is equal to 4 over alpha beta. Alpha beta is 7. Therefore, 1 over alpha plus 1 over beta is equal to 4 over 7. II asks us to find the value of alpha squared beta squared. Again, what we know is alpha beta and not alpha squared beta squared. And of course, in the problem, we are given that alpha beta is 7. And we are not given alpha squared beta squared. So like I said before, all we need to do is to try to rewrite the expression in terms of alpha beta or alpha plus beta or both, where it is possible. But what I see here is that if I apply my elementary set of indices, I can write this as alpha beta all squared. So that alpha beta, which is 7, becomes 7 squared. And that's equal to 49. And that is all about the problem, about that particular case. We have to find the value of alpha squared plus beta squared. The problem is the same. What we know is alpha plus beta and not alpha squared plus beta squared. So we must look for a way to rewrite this expression in terms of alpha plus beta or alpha beta or both. That is alpha plus beta and alpha beta. Now, in this situation, what comes to my head is the difference or the square of a sum. What I mean is this. I have alpha plus beta all squared. This is called the square of a sum. And let us try to expand this square of a sum and see where it leads us. This simply means alpha plus beta times alpha plus beta. If we expand, we have alpha times alpha is alpha squared. Alpha times beta is alpha beta. Beta times alpha is alpha beta, or beta alpha is the same. Plus beta times beta is beta squared. So if we rearrange this, we're looking for alpha squared plus beta squared. I've seen it here. I've seen alpha squared. I've seen beta squared. So So I bring it together, we have alpha squared plus beta squared plus alpha beta plus alpha beta is 2 alpha beta. So what does this mean? This means that alpha plus beta all squared, the square of a sum, is equal to alpha squared plus beta squared plus 2 alpha beta. But what we are asked to look for was alpha squared plus beta squared. So we can make alpha squared plus beta squared the subject of this formula, of this equation. And that becomes, so that means that alpha squared plus beta squared is equal to alpha plus beta all squared minus 2 alpha beta. What do we observe here? We observe clearly that we have been able to express alpha squared plus beta squared in terms of alpha plus beta and alpha beta. All we now need to do is to substitute the values given in the problem. So we are told in the problem that alpha plus beta is 4 and alpha beta is 7. So this implies that alpha plus beta is 4. So this is 4 all squared minus 2 into alpha beta is 7 times 7. So this gives us 4 squared is 16 minus 2 times 7 is 14. So that 16 minus 14 is 2. Therefore, alpha squared plus beta squared is equal to 2.